Let's try to understand TCP state diagram. Here what you have to learn is what are the inputs your client and server are going to take and what are the states they are going to take. So these states are going to give you behavior of client. Okay. So initially your client is at closed state. That means I am only talking about client now. We will see what are the different states it is going to possess. State is a behavior. So when your client is initially at closed state, I am talking about TCP client. That means TCP layer, especially at client. So initially that application layer says that my dear TCP, please open the connection. For that, this input will be given to your TCP client. Okay, client process gives you input connect. Whenever you get input connect, what is your reaction? I am talking about TCP. Okay, the reaction is TCP is going to send SYN request, right? So I can say this is the action which is taken by your TCP client. After that, it will change its state because it changes its behavior. It was initially idle, right? That means in a closed state. But whenever SYN is sent, it is going to another state, that is SYN sent state. Now we have to remember that we sent SYN, I mean one SYN, right? So after that, what are we going to do? We will see. We will be waiting for the acknowledgement, right? And at the same time, so we are going to expect SYN packet also. That means I am going to expect, because it's a three-way handshake process. Just now one step is done. Second step is what? Getting SYN plus ACK. So when you get SYN plus ACK input, where are you going to, I mean, what is your behavior? When you get SYN plus ACK, that means connection is established. That's why we have to go to established state. So that's why I put IHG like this. Okay, that means SYN plus ACK should lead this state to established. That means now recall, initially client is here. That means your client TCP is here. When application process says connect, then we send SYN and we went to SYN send state. After that we'll go to established state after getting SYN plus ACK. But whenever you get SYN plus ACK, do you keep quiet or you send anything? We send ACK back, right? For server. That's why this is the reaction or action, I can say. So this is the input. Input connect, then send SYN as output. And whenever SYN plus ACK is your input, that means if you I can say when you take this input, you send ACK. Done. So after that, what are you going to do? We'll see. We are in established state. When connection is established, we are going to send some data, right? So in this state, we will be happily doing data transfer. After that, what are you going to do? We have to close the connection. What is the first input we should give? I mean, are you going to wait for anything? Yes. Again, your client is going to say that close the connection. So whenever your client says close, then what is your reaction? What are you going to do? Which action you take? Simply we send FIN packet. We know that, right? Recall again three-way handshake and four-way handshake. So in the three-way handshake, let's first of all take four-way handshake. Okay. In the four-way handshake, what are we going to do? We are going to, that is actually, remember one thing, four-way handshake is the general thing, correct? Not three-way. Why? Because sometimes we have to send the, whenever client wants to close the connection, simply only client side connection should be closed. Still server may need something else, right? Server has to send some data to you. That's why. So we use here, let's say, four-way connection. So close FIN. Whenever we send FIN, we will go to this state. What is this state? FIN wait 1. What is the meaning of this one is we just sent FIN and we are waiting for the acknowledgement. Okay. What if acknowledgement is received? Then what are you going to do? You see. Then when you get acknowledgement, and tell me, what is the action you are going to take? I sent FIN and I am waiting for acknowledgement. I got it. Then I should go to FIN wait 2. Why? Why FIN wait 2? Why don't you close it? I will tell you. Only one-way connection is closed, right? I can say that FIN wait 2 is a state where it represents only client's connection is gone. And what is this state? We simply sent FIN request, but still connection is not gone because it may not be accepted by your server. Otherwise, it may not be received to server. That's why we are waiting here just for the acknowledgement of the server. Once you get the acknowledgement, our connection is closed. Only one way, right? But there are two ways. So we sent fin, we got acknowledgement for that, close the connection. But only one side. Still second side is there, remember. So here we will be waiting in this fin wait to state, correct? So after that, still you may get data from your server. But after some time what happens? Server also, will be done with you. Then it will be sending what? Is again fin request, correct? So you are going to get some fin request from your this one. What is that? Your server. Then what is the reaction from you? You should send acknowledgement. But you have to go to timed wait state. I will tell you the reason. So you just remember that whenever the second direction also closed, okay, just now it is closed because you got input fin from the server. Server sent fin, then you sent request ACK, then you went to timed wait. Remember this point. I will tell you why we go to timed wait. Why don't you directly close a complete connection? It's supposed to be like this actually, but we don't do that. The reason why we go to a temporary state, this is a temporary state, remember, but I will discuss that later. So we will go to timed wait after some time. I will tell you this sometime also. What is that? At this moment, let's say sometime. After some time we will close it. Why we have to wait, we will see later. This is general path of your client. Now we'll see server path also. Okay. Now we'll see various paths which are taken by your server. Okay. So the server, I am talking about TCP server. Now initially that server process will execute a command called listen. Initially your TCP will be in closed state. Then so listen will be called. Whenever listen is called by process, then your TCP will go to a state called listen state. Okay, but it won't output anything. Now when in listen state, what your server is going to do? It is going to listen for SYN packets. So eventually after some time SYN packet will come. Whenever SYN comes, what your server is going to do? It is going to send SYN plus ACK, correct? So I can say that whenever server is in listen state, if it gets input SYN, it is going to SYN plus ACK and it says that I received a SYN. And of course I also sent SYN and plus ACK for this one. Now I am expecting ACK for my packet, my SYN packet. Then connection will be established. Then I will happily go to established state. That's why when you are in server is in SYN received state. So it is expecting ACK packet from the other end of the connection. So eventually it will get it, right? So for input ACK, it won't do anything, simply no action, but it will go to another state called established state. Now see, this is client path, this is server path. Let's see one more time server path. Initially you are listening, right? Whenever you listen, go to listen state, and that whenever you get SYN packet, send SYN plus ACK and go to SYN received. In this SYN received, if you get acknowledgement, then go to established because connection is established. You see just SYN plus ACK, ACK. That will eventually will make your server in established state. So after established state, what are you going to do? In established, again some data transfer, right? Once data transfer is done, then your client is going to send you FIN packet by saying that connection is closed. So that is the regular thing. So I can say that whenever you get a FIN packet, what you have to do? Then generally whenever you get a FIN packet, so quite normal thing is, you should go to four-way handshake because you are a server. There are two things you can do, three-way handshake, otherwise four-way handshake. But four-way handshake is, general thing because we have to close only one-way connection. Other way connection we have to keep, correct? So that's why whenever server gets FIN packet, it simply sends ACK and it will go to, what state? Close wait state. Okay, that means the meaning of close wait is generally server comes here. I got FIN packet. That means client's connection is closed. This is client. This is server. This connection is closed. But from servers to server to client still is there. When I will close it, my server process will tell that maybe my server process has some more data to send to client. That's why I don't close my connection. I will wait here. So after some point of time, what happens? Your server will finish its task and it will send close connection. So that means here your server is going to issue, I am talking about server process, close connection. then immediately on behalf of that server, we are going to close the connection. For that, what we send finish packet, right? So fin is the action, and we'll go to last ACK state. That means what? This connection is already gone. That's why we are here. Now our data transfer at this direction also done. Now we are about to close it. For that, we are sending fin packet. Then the client is going to, whoever it is, the other end person is going to send us ACK. That means before sending it, what is our state of mind now? We are just expecting ACK. That is the last ACK. If you get it, completely closed. That's why. So we are at last ACK now. When you are in last ACK, when you are expecting ACK, it will come, right? Eventually when it comes, what you are going to do? So we are going to directly go, close the complete thing. That's why. So last ACK, when you are at last ACK, when ACK comes, then we go to closed state. We don't go to timed wait. I will tell you the reason for that. So generally, so this directly last ACK to ACK is closed. Okay, but for fin wait to if you get fin, then you will be sending ACK, and we are going to timed wait rather than closed. So why this timed wait, we have to discuss. Okay, let me postpone that. Sometimes what happens, both ends simultaneously send SYN requests. Then that is very rare case. In that case, what happens, we'll see. Here there is no client, no server. Both systems at a time want to send SYN packet. Example, A sends SYN packet. At the same time, B also thought of sending SYN packet. So what is going to happen, we'll see. Generally, whenever it happens, this is called simultaneous request. Then here, first of all, we see A's point of view. So at this point of time, A thinks that why I got SYN, because I sent SYN, then really that other side receives it, then it would have sent SYN plus ACK. But it sent SYN means what? Definitely there is a problem. That means it's a simultaneous request. Then A is going to send SYN plus ACK. We know one thing, right? Whenever you get SYN, what you send? SYN plus ACK. This time A sends SYN plus ACK. Okay, slowly it will receive. Now at this point of time, what B thinks, we'll see. At this point of time, B thinks like this: I got SYN, but already I sent SYN. I have to get SYN plus ACK, but I didn't get. That means what? It is simultaneous request probably. Then B also sends SYN plus ACK. Okay. Now we will see here A's point of view. A already sent SYN, then B, it got SYN back. Again it sent SYN plus ACK. So that means what? When we'll see here this point of time. So here whenever SYN plus ACK is received, now A can think like this: this is B's SYN, but already this is my acknowledgement. That means my SYN is already gone. So and now I got SYN of B. That means what? Two SYNs. Two SYNs means what? Definitely it's a connection establishment. Now A will realize at this point of time that there is a connection. That means connection has been established. So what about, there are two ways. Simply you see like this. How A will know that this kind of connection is established already? Because it got acknowledgement. How A knows that this connection has been established? Because it just now it sent SYN. That's why by seeing these two, then we can say that this ACK for this one and this connection request is just now arrived. So finally your sender is going to, otherwise this end is going to establish state. Now we'll see B's point of view. Whenever this SYN plus ACK is arrived here, same story. Already B sent, see this ACK says that A to B connection, sorry, we have two, right? A to B, B to A. Okay. This ACK says that A accepts B's request. That means B to A connection is accepted. Now, just now we are getting SYN packet one more time. That means what? Already we got it. With that we can understand that A to B connection is also established because it is requesting, A is requesting it, correct? So finally by seeing this SYN and SYN plus ACK, always we can go to established state, remember it. Now I am going to apply the same concept in this picture. Okay, so far we have seen some of the client behaviors and some server behaviors, right? Now sometimes what happens, already just we have discussed, right? A and B simultaneously send SYN packets. What is going to happen, we'll see here. Neither A is SYN, neither A is client nor B is client. Similarly, neither A is server nor B is server. So they send SYN packets to each other. Then what happens? Whenever A sends SYN packet, you see, we are initially enclosed. Whenever we are sending SYN packet means what? Definitely the process asked us, right? That means the process, corresponding process asked us to connect to the destination. That's why we are going to send SYN packet. Whenever SYN packet is sent, we are going to SYN sent. Sir, here who is going to go SYN sent? Client or server? Here there is no client server because both are behaving like clients. That's why, because of SYN packet, A will come to SYN sent state, B also will come to SYN sent state. Okay, now let's focus on A. Now A is in SYN sent state in this model. Then what is going to happen? It is going to send SYN plus ACK whenever it receives SYN packet. So that's why when you are in SYN sent, this kind of unusual thing happens. That is, when SYN is arrived, that means definitely I can understand that it is simultaneous request possibility. Then immediately SYN plus ACK will be sent. Okay. Now at the same time, B is also going to do what? B is also sending SYN plus ACK. That's why B is also having same edge. B is now at SYN sent state after sending SYN, correct? Now if it gets SYN again, that means it will understand that there is a possibility of simultaneous SYN. That's why immediately it will send SYN ACK. So A and B both will go to SYN received state. Okay. Now we'll see what happens in this simultaneous access process. Initially A is at, let's take A. A is at closed state. After sending SYN, it is going to SYN sent state, right? Now A is at SYN state after sending SYN. Then what happens? See, it is going to get SYN packet. Whenever it gets SYN packet, it is going to send SYN plus ACK and it is reaching SYN received state. We know that. This is the new edge. Okay, all blue color things I am going to teach, which are generally unusual. Now after that, what are you going to do in SYN received state? We will be waiting for ACK from B. Let's recall, you see. SYN, then SYN plus ACK you are sending. After that, we are waiting at SYN received state. I can say this entire thing is SYN received state. Then you get SYN plus ACK, but of course already we got SYN. The extra thing what you are getting ACK. That's why when you get ACK, then we are going to establish state. This is not only true for A, it is true for B also, isn't it? Because A and B are having same property. So that's why whoever is here, they get SYN packet. Then that will be simultaneous request. Then they will go to SYN received. After that, if they get ACK, they will go to established state. That is one thing. Now second one, when you are in SYN received state, that means you just got SYN, right? Whenever you get SYN, suddenly this restart input comes somehow. That means did you remember, whenever restart function is called by anyone, then definitely the process has to go back. Okay, it should restart the connection. Okay, that's why we'll go to listen. That is quite obvious. Next one, you see this one. This is done already. We are covering all the blue things. This is done. Now you are in SYN send state. Whenever you send a SYN anyone, generally will go to SYN send state. Okay, generally client will go, but usually, so sometimes in this kind of cases, very rarely, so there is no client, there is no server, everyone will be like same and they will go to the SYN send state. Okay, so there are two variations. Generally 90% of the time we use client server model. That's why I taught all the edges related to that client server model. But there are some unusual things like there is no client, there is no server at that time. So whoever sends initially SYN, they will go to SYN send state. When you are in SYN send state, any protocol, otherwise any, I can say TCP entity, then if that process, application layer process, initiates close action, then what we are going to do? We are going back from where we came from closed, right? Closed on connect, we came to SYN sent. On SYN sent again close will go to closed. That is the meaning of this one. Then anything else? This one, you see, when you are in fin wait one state, that means what? Just now we got orders from our higher layer that send fin, correct? That's why we sent fin. After sending fin, any entity will go to fin wait one state, correct? Then suddenly, if from other end also if you get fin, what is this? Is surprising, correct? See the story. There are two ends again. Now it is not routine model like client server. So A sent fin packet, B also sent fin packet. Now what are you going to do by seeing this fin packet? is the question. If you get fin, then immediately for that fin we have to accept it, correct? That's why we have to send acknowledgement by saying that yes, okay, no problem, we can disconnect it. So that's why here whenever you are in fin wait 1 state, if fin comes, send acknowledgement for that and go to closing. That means now you are closing it. Okay, so remember that one. From closing, if you get again ACK, that means what? Already you sent fin. That's why you were in fin wait 1. Try to understand. Already you are in fin wait 1 means what? You sent fin and you are expecting ACK, but you got fin. Then you sent ACK for that fin and you went to closing state. On that closing state, if you get ACK, that means it is for your fin. Then go to time wait. That means it is like almost closed state. Okay. I will tell you the reason why we go for time wait state rather than directly closed. Okay. Now at this moment directly time wait. Now see this edge. What is this edge? You are in fin wait 1 state. You got fin plus ACK. That means what? Recall. When you send fin, you are getting fin plus ACK means what? That server also want to close its connection. Server is accepting your ACK. Then you will be happy. Nothing to wait, right? You are waiting for ACK. See, otherwise I will tell you shortcut. When you are in fin wait 1, after getting ACK, after getting, after getting fin and after getting ACK, fin plus ACK, you reach time wait, right? But directly in one packet, if you get fin plus ACK, you supposed to go to time wait. That's why when you are in fin wait 1 state, if you get fin plus ACK, then complete connection we can close. That's why time wait. So these are all the possible edges in this model. TCP. Okay, so don't by heart it, otherwise try to understand the logic behind every state, then after that you try to remember it. Okay, sometimes in GATE exam they are asking questions related to this diagram, that's why so I am focusing here. You also just remember all possible states and how at least very easy question they ask. They don't ask very rare cases like this one, but they ask very easy things. That's why if you remember this picture, so easily we can answer that easy things. Okay, now we'll see why this time wait state is required. Okay, so initially let's say A and B are exchanging the information. So connection has been already established. Now data transfer phase is done. That means data is transferred. Now A is issuing FIN request. Okay, so we say that A is a client because he initially started closing the connection generally. Okay, otherwise we say that it is active close. Whoever closes the connection first, that is called active close. So A is actively closing the connection. Then what happens? A is going to fin wait 1 state. If you see the transition, you understand. Whoever closes the connection, then they will become active close. They will go to fin wait 1 state. In fin wait 1 state, so whenever you are here, then you are expecting acknowledgement for your connection. If you get acknowledgement, then you go to fin wait 2 state. Correct? Did you remember? So this means one side connection is gone. A side connection is gone, but B side connection has not yet gone. For that, B has to send FIN request. We are expecting FIN request. Whenever you get FIN request, then we will be happy because we are about to close the second direction also. For that, we send ACK for that FIN packet and we go to time wait. Why this time wait? And you know this shortcut also, right? Suddenly, if you send FIN packet, your server sends FIN plus ACK, then also we can close the connection. That is three-way handshake, right? Generally, this is regular process. This is not regular. Now, in this model, why we have to come to time wait directly? Why don't you close the connection? For that, you should understand this story. A and B are two, end systems. They want to communicate. Okay, so A is sending, segments. Before that, there will be connection establishment. Correct? Assume that these edges are all related to connection establishment. I am not showing the details. After that, this is the data transfer. So packet 1 and packet 2 and packet 3. These are the data packets. There may be some of the duplicates also. Why, sir? Example, sometimes one packet is not received, or if there is any error in the packet, we will be retransmitting it, right? Did you remember go back and protocol, SR protocol? There in whenever there is an error in the line, we retransmit the packets. That's why finally, so in this P1, P2, P3, P4, some packets are valid, original, some packets might be duplicate, correct? But doesn't matter. So we will be taking only correct packets because we have sequence numbers. If there is a duplicate packet, there will be, inappropriate sequence number for that, we can discard, right? That's why we use sequence numbers and acknowledgements. But did you remember, already we have seen in go back and protocol, SR protocol, using the sequence numbers and acknowledgement numbers, we can happily have the connection and data transfers, correct? So without allowing the duplicates. But the problem, you see, after closing the connection, assume that, let's say, data transfer is over. Now A and B are closing their connection. This is the establishment of the connection. This is the closing. Now one of the packet P1, let's say, otherwise let's say P3, that got delayed. That is, that is not reached to B in this connection. Again A comma B opened one more connection immediately. Now this is, let's say, data connection opening. Okay, after that they started transferring the data. See now, one of the delayed packet P3, if it is delayed so much, still it is in network, suddenly it might come to B, correct? Because that packet is also, its destination is B only, but the only thing is, rather than in this connection, it is coming in another connection. That is possible if you open a connection immediately after closing the connection. So I can say that this packet P3 is wrong packet, but B of course will detect it. Why? This set of sequence numbers will be different from this set of sequence numbers, correct? So there is a difference in sequence numbers. Here, let's say if you started with sequence number 100, it is not guaranteed that again we start with sequence number 100, correct? We may start at 200. Did you remember? That's why we start our sequence numbers randomly. If you always start with 0, there is a high chance that this duplicate packet will disturb us. That's why we use random sequence numbers. Sometimes in that random sequence number generation also, what can happen is, so there may be a, I can say, collision. That means if you start with 150, assume that this packet P3 sequence number is something 170. Okay, now here there is a packet called P something 4, P1, P2, P4. This is P5. P5 is the original packet of this connection. Its sequence number is something 160. Now here P3's sequence number is 170. Sometimes what happens, this 170 will cheat B, that it says that P3 says that, see my dear B, my sequence number is after 160. I am also valid packet, but it is not valid. But exactly all the values it is carrying matches with this connection sequence numbers. So immediately B will take it. That is a mistake. How to avoid that? That's why what we do is, so whenever you open a connection, the only problem is one connection should not disturb another connection. That's it, right? For that, we wait for, all the packets die. Did you remember? In network, there is a packet lifetime, correct? What is a packet lifetime? Go to network layer. In the network layer, for every datagram, there is a time to live field. So that is going to decide the packet lifetime. After some time, TTL value will become 0 and we are going to discard the packet. So in that way, every packet has lifetime. So that lifetime generally will be 1 minute, otherwise 30 seconds, okay, typically. So by observation that will be, calculated. So this value will be taken. Example, let's say packet lifetime is 1 minute. That means in an internet layer, otherwise network layer is going to kill the packets, however, after 1 minute. Sir, how it is related to our problem? We are in TCP, right? Remember one thing, your TCP data is carried by your datagram. There is no difference between datagram and TCP data. TCP data is encapsulated into datagram and it will be carried, right? It will be transferred. So that's why if datagram is dead, your TCP segment also dead. That's why. So here we are going to introduce maximum segment life. Every segment will have some life in the network. That it depends on this time to live field. That's why assume that, let's say, maximum segment life will be decided as 1 minute. Okay. So it will be, it is not fixed to 1 minute or 2 minutes. Okay, it depends on the designer's choice. They will fix something. Okay, it will vary. That's why at this moment don't blindly remember that value, but you remember that there will be some value for maximum segment life. So that's why here what we do is, whenever connection is closed, we don't really close it. Here this is the time to close the connection, but we go to time wait state and here we wait for like that 1 minute of time. That 1 minute is typically to maximum segment lifetime, okay, 2 MSL, remember it. That is the way designers fixed it. Okay, you understood the concept of what is maximum segment life, right? So we wait for one maximum segment life or two maximum segment lives, then we close the connection. Understand? So this is the meaning of time wait state. Especially we go there and we wait for some time. If you do that, then when you open the new connection, this old connections data is already completely dead. There is no single packet in the network which is related to this one, so there will not be any problem. That is about time wait state. Okay.